Hello everyone, this is the first lecture on the binomial theorem, and the binomial theorem is related to the function a plus b raised to n. Now, this is going to be the core subject matter of this chapter. How do we evaluate a plus b whole to the power n? And we are also going to look at different problems based on the whatever we learned in this subject. So, to start with, this is something that you all know. We are going to start with a plus b whole squared, and this is something that you all know. You have all studied this. This is a squared plus 2 times a b plus b squared. You all know why this is true. Next, you can do a plus b the whole cube, and this is also something that you all know. A cube plus 3 a squared b plus 3 a b squared plus b cube. Now, there are two more things that you know I did not write, and one is a plus b whole power 1. So, that is, so let us there is no space over here, a plus b whole power 1, and that is equal to a plus b. And there is one more non-trivial result, although very easy, and that is a plus b whole power 0. And what is that? What something to the power 0? It is equal to 1. Great. So, these are things that you already know. Now, I am sure some of you who are listening to this lecture know more than this. You also know a plus b whole power 4, a plus b whole power 5, 6, and so on and so forth. You might know some of these things. However, is there a pattern? Now, a lot of people have thought about this. You might have thought about this yourself, and you might already know the answer, and there is a pattern. The pattern is as follows. So, this pattern is called the Pascal's triangle. So, you start with a 1. So, the triangle goes along two edges, right, and you can terminate the triangle wherever you want. So, you write 1s on these two sides of the triangle. Now, you start with 1, this is a plus b whole power 0, and then a plus b whole power 1 has 1 times a plus 1 times b, right. So, that is your second answer. So, the Pascal's triangle is going to give you the coefficients of each of these individual terms. The third one is a plus b whole squared, and what you do is from these two 1s you add them and you get a 2. Then the next one is a plus b whole cube. Okay, so, a plus b whole squared, this is 1, you have a 2 over here and you have a 1. I hope it is clear. And then a plus b whole cube, what you do is you need to find the intermediate terms. So, you get a 3 over here, you get a 3 over here, 2 plus 1 is 3, right. So, it is 1, 3, 3 and 1, and you look over back at a plus b whole cube, it is 1 times a cube plus 3 a squared b plus 3 a b squared plus 1 times b cube. So, you have got the coefficients all right, and then you can predict that if all this is correct, then hopefully 1 and 3 will give me a 4 over here, and 3 and 3 will give me a 6 over here, 3 and 1 should give me a 4, and this should be related to a plus b whole power 4, and then a plus b whole power 5 will be 1, 5, 10, 10, 5, 1, and then a plus b whole power 6 will be 1, 6, 15, 20, 15, 6 and 1, and so on and so forth. So, this is fairly straightforward. This is called Pascal's triangle, and guess what, who came up with this triangle for the first time? It was Pascal, but there are many other people who came up with this. There are even reports of this being known to ancient Hindu mathematicians. There are several, I mean, if you ask me, it is not terribly hard to figure this out. Even as a school student in class 5, class 6, you might have figured this out yourself too, without the help of Pascal or anybody else. Okay, so this is not something very hard. What's hard is, what if I ask you, what is a plus b whole to the power 95? What will you do? Are you going to start writing this triangle and make it go 95 steps and then give me the answer? Is that what you are going to do, or are you going to do something smarter than that? And this has bothered many people, and indeed mathematicians have figured out how to do something in a much smarter way. And the idea behind that is as follows. The idea is, if I plan to do a plus b, and let us not do 95, let us do something smaller, let us do 7. Okay? I am going to take that as an example. So, let us say you want to do a plus b whole to the 7. How will you do it? So, one way is to do a plus b times a plus b whole to the power 6, but I will not do that. I will do a plus b times a plus b, and I am going to write this seven times. Okay. I have written this up 7 times, and now what is your job? Your job is to do these 7 multiplications, and instead of doing 7 multiplications one at a time, let us try and do all of them at the same time in one shot. How are we going to do it? So, the first thing you can do is, we will take a from here. So, we will take all the a's together. So, we will spread all the factors out, and let us take all the a's. So, a times a times a times a times a times a, and that happens to be equal to a power 7. That is the first term, that is the easiest one. Next, what we are going to do is, just for the first term and only for the first term, we are going to keep the b. We are going to use b only for the first term, and then all the others let us use a. So, what will that give me? That will give me a power 6 times b. Now, just like you picked b only from the first term and the remaining were all a's, you could have also picked b from the second one and the remaining others could have been a's, right. So, you could have chosen any one of the 7 b's, right, any one of the 7 b's could have been chosen. So, you do this 7 times, am I right? You do it 7 times, you do, this is the first time you do it, the next time you pick this b and remaining all a's, the third time you pick this one as b and remaining all a's, fourth time you pick this one as b and all other a's, and so on and so forth. Like this you can pick b 7 times, and 7 times you will get the product as a power 6 times b. So, therefore, you end up with the second term as 7 a power 6 times b. Now, what are you going to do next? What we are going to do next is, we are going to say that let us have this as b, this as b, and the remaining 5 will keep as A's, right. So, what are we going to get? We are going to get A power 5 times B squared. Now, you could have picked just these 2 as B, you could have picked any 2 as B, any 2 out of the 7. So, you could have chosen any 2 out of the 7 terms as B, right, and you add them, add all of these terms one after the other. What do you get? What is that process called? You have 7 elements. You have got 7 elements and you are being asked to pick any 2, and how many different ways can you do such a thing? How many different ways can you pick these 7 elements? So, that has a shortcut, in short that is called 7 C 2. Remember, this is from your combinatorics, right. So, 7 C 2, how many different combinations of, how many combinations of 2 choices can you pick out of 7 possibilities? What is 7 C 2? Just by the way, 7 C 2 is 7 factorial 7 divided by factorial 2 divided by factorial 5, right, and factorial 7 is 1 into 2 into 3 into 4 into 5 into 6 into 7, right. Factorial 5 cancels out the first 5 terms. So, these 2 partially cancel out and you are left with 6 into 7 over here, and factorial 2 is just 2. So, this 7 C 2 is nothing but 21. Next what you can do is, so this completes A power 5 times B squared. Next you say that I am going to have 3 such terms as B and remaining 4 I will keep them hanging around as A's. If you do such a thing, what will you get? You will get A power 4 B cube, right, and how many possible ways can you do this? How many different ways can you choose 3 B's out of 7 possibilities, right? The answer is 7 C 3. And what is 7 C 3? 7 C 3 is 5 into 6 into 7 by 1 into 2 into 3, and that gives me 35. And then next what you can do is, you pick 4 B's and the remaining ones you keep them as A's. So, you end up with A cube B power 4, and how many different ways can you do this? The answer is of course 7 C 4. Now, 7 C 4 is factorial 7 by factorial 4 by factorial 3, right, and factorial 7 by factorial 4 is again 5 into 6 into 7 by factorial 3 is 1 into 2 into 3. So, you get the same answer as before. Is that a surprise? Is that a surprise that you got these two as the same? So, how many ways can you pick 4 B's out of 7 is the same as how many ways can you pick 3 A's out of 7, right. And in the last exercise you did how many ways can you pick 3 B's out of 7 possibilities. So, 7, if you have a pool of 7, how many ways can you pick 3, and the complement of that is how many ways can you pick pick 4. So, they are supposed to give you, they should give you the same answer, and we have got the same answer for both. All right, and then what is going to be next? So, this is not yet done. Next you can say that I will keep 5 terms as B and 2 of them as A, and that will give me a squared b power 5, right. And how many ways can you pick 5 out of 7? The answer is 7c5, and 7c5 happens to be equal to 7c2, and that is once again equal to 21. And then lastly, not lastly, I am sorry, there are 2 more terms left. You can have 6 B's and only 1 A. So, which one of them is going to be A? There are 7 possibilities clearly, right. So, how many ways can you pick 6 B's out of 7? That is 7C6, and 7C6 happens to be equal to 7C1, which is equal to 7. So, this answer is easy. And lastly, you say that I am going to collect all the B's together, and that leaves me with b to the power 7. So, this is your answer, and guess what? We did not have to rely on Pascal, we came up with the answer straight away, right. And in short, this is what the entire chapter is about. The entire chapter is about the binomial theorem. What we just worked out was actually, I will state the theorem. The theorem states that a plus b whole to the power n is nothing but a to the power n plus n c 1 a to the power n minus 1 b plus n c 2 a to the power n minus 2 b squared plus n c 3 a to the power n minus 3 b cube, and so on and so forth, all the way till n c n minus 1 a b power n minus 1 plus b power n. And it so happens you can in fact write this as n c 0, right. 1 is nothing but n c 0. How many ways can you choose none of n things? There is only one way you can choose nothing, right. This is n c n. So, in the language of mathematics, when there is something complicated that looks like this, we try to compress all of this in mathematical shorthand, and the mathematical shorthand looks like this. This is a sum of many terms. So, a sum is usually expressed as the capital Greek alphabet sigma, and inside this sum you have what? You have n c and then something, it could be k, right. Imagine the kth term, actually we are going to use the k, yeah, the kth term is fine. Right. So, if you look at the kth term, any general term out of this, let us say the third term. So, instead of 3 you write k. So, you get n c k a to the power n minus k b to the power k, right. So, k can be equal to 3, k can be equal to 0, 1, 2, 3, 4 all the way till n. So, k goes from 0 all the way till n. So, this is the mathematical shorthand notation. So, sigma means a gigantic summation, right, sum of all of these terms, and this is how we compress such a complicated formula into shorthand. Okay. So, this is pretty much it. This is the binomial theorem. Now, of course, knowing just the theorem is not good enough. We need to look at a lot of its applications. So, our first, let us say, corollary is going to be a minus b to the power, let us say 7. Let us do 7 because we did 7 last time. So, this is what we had done, a plus b whole to the 7, and now I am asking you, if you know how to do a plus b whole to the power 7, can you also tell me what is a minus b whole to the power 7? And the answer is quite straightforward. All you have to do is, in the old expression, you replace every b with a minus b, right. You have the old expression, a plus b whole power 7 is equal to a power 7 plus 7 a power 6 times b plus 7 c 2 a power 5 times b squared, etc., etc. Now, in this old expression, for every b you write minus b and you get a minus b whole power 7. So, what is that? That is equal to a power 7 and then minus 7 a power 6 b, and then over here you have got a b squared. So, b squared means you replace b with minus b, you end up with a plus b. And then you have got 7 c 3 times a power 4 times b cube, right. You replace b with a minus b, you get minus b cube. And then you have 35 a cube b power 4, you replace b with a minus b, you still end up with b power 4. And then next you have 21 times a squared b power 5. What is this going to be? This is going to be minus 21 a squared b power 5. Thank you. And then you had 7 times a times b power 6, you replace b with minus b, you still end up with b power 6. And lastly, you had b power 7, you replace b with a minus b, what will you get? You will get a minus b power 7. Great. So, this was our first corollary. If you know how to do a plus b whole power n, then there should not be any reason why you can't do a minus b whole power n, and I will not get into the formula, it is just an extension of this. All right, let us do one quick application. One quick application is something that you possibly have not studied. So, you have studied simple interest in banks, right. Banks give you simple interest, but in real life interest is not that simple. So, you deposit, let us say 1000 rupees in the bank, and the bank is going to give you 6% interest. Now, if you keep this for 1 year, then the bank gives you 6%. So, let us do an interest problem, right. This is an extension to arithmetic. Let us look at this application, right. I am picking this interest as an application. So, you keep money in the bank, 1000 rupees, 6% interest, 6% interest per annum. Now, of course, if you keep it for 1 year, then 1000 rupees, 6% interest will give you 60 extra rupees. So, you end up with 1060 rupees, right. So, it becomes, so if you keep a principal p, then at the end of 1 year you get 1.06 times p, right. What happens at the end of 2 years? At the end of 2 years you do not start from p, you do not get 12%, you start from 1.06 p, and what do you get? You get 1.06 into 1.06 p, right. This is something that you did not learn in school, or maybe some of you did, but this is what happens in real life. In real life you do not get 6% year after year on the same principal. In real life the principal grows. So, you keep principal p today, after 1 year it becomes 1.06 times p, and now that is your principal. So, the next year around you will get 6% on that new principal, right, as your interest. So, you end up with 1.06 times 1.06 times p. What happens if you keep this money locked into the bank for 20 years? What is going to happen? You are going to get, I mean in 1 year it is 1.06 p, in 2 years it is 1.06 square p, in 20 years it is going to be 1.06 whole power 20 times p. This is how much your money has become if you keep the money in the bank for 20 years. Now, how will you do this? Of course, one easy way to work this out, 1.06 times 20 is to the power 20 is to punch in the numbers in a calculator and work it out, right. But that is not what we are going to do in a mathematics class. In the mathematics class we are going to break this up into 1 and 0.06, and then we are going to do whole power 20, right. And what will you get? You will get 1 power 20. Always remember, you do not have to memorize the formula. This is the grand formula, right, but no memorization needed at all. Do not try to memorize this. In fact, I am teaching this class, but I do not memorize this, right. I worked it out right in front of you from scratch. So, I do not memorize this, neither should you. No need to memorize this. If you are asked to do 1 plus 0.06 whole power 20, you should be able to do it from first principles, right. How will you do it? You are going to break it up into several pieces, 1 plus 0.06, 1 plus 0.06, 1 plus 0.06, 1 plus 0.06 many times, 20 times, right. And then you choose the ones, you multiply the ones together, then the next step you multiply some 1s and some 0.6s and so on and so forth. So, what we are going to do is we are going to break this up 20 times. I am not going to write it, of course, because writing something 20 times seems extremely foolish, right. I do not want to write the same thing 20 times. I am not doing handwriting practice, so I will not do it. You also should not bother writing the same thing 20 times, but the understanding, what should be inside your head is that you are breaking this up 20 times. So, you do 1 plus 0.06 whole power 20. The first step is to pick 1 from all 20 of those terms. So, you get 1 power 20, which is nothing but 1. In the next step you pick 0.06 from any one of those 20 terms, and the remaining all should be 1s. So, you get 0.06 times 1 to the power 19, 1 to the power 19 is obviously 1. So, you get 0.06 only, and how many possible ways can you pick the 0.06? There are 20 C1, right, which is nothing but 20. All right. So, this is the first term. Then what do you do next? You are going to pick any 2 of the 0.06s, remaining 18 should be 1s, right. How do you pick 2 of? So, you do 20 C2. There are 20 C2 different possibilities of different ways of picking 0.06, right, and the remaining will all be 1s. So, into 1 power 18, which I am not going to write. Then what is going to be the next term? The next term is going to be 20 C3 times 0.06 whole cube, and then the next term is going to be 20C4 0.06 whole power 4 and so on and so forth, right, many terms. But look at this, let us quickly try to look at this. Let us try to evaluate some numbers because I am doing arithmetic. So, this is a 1, 20 times 0.06, what is 2 times 0.06? It is 0.12 and 0.12 times 10 is 1.2. Okay, very nice. 20C2, how do you work out 20C2? 20C2 is nothing but factorial 20 divided by factorial 18. So, 18 out of those 20 terms cancel out, all that you are left with is 20 into 19 divided by factorial 2, which is 2. So, this is equal to 190, all right, and just I will keep this result also on the side. How do you do 20C3? 20C3 is nothing but factorial 20 divided by factorial 17. So, 17 terms have cancelled out, and then what remains? 20 into 19 into 18, that is what remains, and then the whole thing divided by factorial 3, which is 2 into 3, right, and this gives you 190 times 6, whatever that is, right. What is that? 1140, is it? Okay. Let us just keep this on the side, and let us also keep 20C4 on the side. I just would like these pre-computed in advance. 20C4 would be 20 into 19 into 7 into 18 into 17 divided by 2 into 3 into 4, which is nothing but 20C3 into another 17 on top and 4 in the bottom. Okay, great. And 20C5 would be nothing but 20C4 into 16 in the top and 5 in the bottom, right. So, just letting you know, and we are going to keep these handy for our nice calculation. All right. So, this is the calculation that we are working on, 1 plus 0.06 whole power 20, and our result is coming out to 1 plus 1.2 plus 20C2, which was 190 into 0.06 into 0.06, okay. And then the next term is going to be 190 into 6, yes, into 0.06 into 0.06 into 0.06, okay. And then the next term will be, so it is the same 1140 into 17 by 4 into 0.06 whole power 4 and so on. So, this is what we want to do, right. Looks very complicated, but look, at the end of the day, if you are a very serious mathematics student, then you are going to work it out very accurately. Now, if you are not that serious about it, if you are a person who is going to work in the bank and who is going to only work till rupees and paise, right, not beyond, he is not going to give you a fraction of 1 paisa, then you do not have to work so accurately. So, let us just see how accurate how many of these terms do we need. If you think about it, 0.06 times 0.06, what is this? This is 0.0036. So, this is becoming a small term. Then the next term is becoming even smaller, right. The next term is 0.06 times 0.0036, right. So, what is that? 0.0002, sorry. So, it has become tiny, 0.000216. Okay. The coefficient is also growing, this term is becoming larger, but the pace at which it is becoming larger is not necessarily the pace at which the other term is becoming smaller and smaller, right. So, you probably do not need to compute too many terms over here. So, the first term is fine 1, the next term is 1.2, which is very significant. The third term is 190 times 0.0036. How much is that? So, 19 times 0.036, right. If you approximate 19 as 20, it is 20 times 0.036, right. 2 times 0.36 is 0.72. So, this is approximately 0.7 something 0.72. I do not want to, I do not have a calculator on me, I just want to get an idea of what the number is going to look like. So, it is something like 0.7. Then the third term, the coefficient has gone up by a factor of 6, whereas the other term 0.06, that term has gone down by a factor 0.06, right. It has become smaller, whereas the coefficient has become larger, right. So, 6 into 0.06 is by the amount by which it has grown, 6 into 0.06 is nothing but 0.36. So, you can expect this entire term to be something like 0.36 times 0.7. So, it has actually become smaller, right. How much smaller? It will become 0.7 times 0.36 is something like 0.22. I do not want to work out the whole thing, it is becoming smaller. The fourth term, the coefficient has grown by 17 by 4, but the exponent, because of the exponent you have shrunk, right. So, it is 17 by 4 times 0.06, right. What is that going to be? 17 times 0.015, right. So, that is approximately 0.085. So, this is now much smaller than the previous one. So, you can, if you say that it is 0.1, then this has shrunk even further, and then the next term you do not have to bother too much about, right. These are becoming smaller and smaller. But what do you see over here? You see that these two terms are not insignificant at all, they are quite significant, 0.7 and 0.22. Okay. So, you started with a principal P 1000 rupees, you ended up with 1000 rupees plus 1200 rupees plus 700 rupees plus 220 rupees plus 20 rupees, right, and the further and further terms are going to become smaller and smaller. If you had worked only with simple interest, you would have got only this first term, this is all you would have got if you had worked with simple interest from your school, right. 20 years you have kept it in the bank, all you get back is your principal and 1200 rupees as interest, right. But for 20 years that is very small. So, if you work with compound, this is called compound interest, if you work with compound interest you get some more, you get another 700, another 220 another 20, and so on and so forth. And all of this is the result of your binomial theorem. Okay. So, this is one small application that we did. All right. In your NCERT book, you will find problems like this. Which one is greater? You might have a problem like this. And what is the answer? You look at 1.01, you break it up into 1 and 0.01. The first term is going to be 1 to the power 1000, the second term is going to be 1000 times 1 to the power 999 times 0.01, 1 to the power 999 is 1. So, this breaks up into 1 plus 1000 into 0.1 plus 1000 C2 into 0.1 squared plus 1000 C3 into 0.1 cube, and so on and so forth. Now, this is clearly I am sorry, this is 0.01. Yeah. Now, this is clearly a 1, and 1000 into 0.01 is nothing but 10. So, that was how I framed the problem. So, I took the first two terms, I added the first two terms in my mind, and I said which one is greater, is 11 larger or 1.01 times 1000 larger, and your answer is going to be 1.01 times to the power 1000 is larger than 11. So, there are quite a few problems in the exercises of your NCERT book that look like this. So, this is a trivial application. Okay, let us do maybe one more or a couple more and see how much we will see how much time we have. So, this is an easy one, 1 minus 2x whole power 5. Now, how will you do it? You are going to take the first term, which is 1 to the power 5, you will pick that 5 times. The next time around you will pick the first term 4 times and the second term once, right. And how many ways can you do this? You can do this 5 different ways. So, you get 5 times 1 to the power 4, which I am not going to write, times minus 2x. And then the third term is going to be, you pick 1 3 times, so it is 1 cube, and you take minus 2x twice. So, minus 2x the whole squared, which is plus 4x squared, right. And how many different ways can you do this? You can pick this 5c2 times. 5c2 is 5 into 4 divided by 2, which is 10. Then the next term you are going to pick 1 only 2 times and 2x 3 times. So, if you pick 1 2 times, that gives you a 1, and into minus 2x into minus 2x into minus 2x 3 times. So, that is minus 8 x cube. And how many different ways can you do this? Out of the 5 sets, you are going to pick 3. So, 5c3. Now, 5c3 is nothing but 5c2, they are the same thing. So, you still get a 10 over here. And then you want to pick 1 only once and 2x 4 times. And how many ways you can do that? You can do that 5 different ways. So, you are going to pick 2x 4 times, means you are going to do 2x whole power 4, that is 16x power 4. and then finally you are going to take all the 2 x's and multiply them together. So, you get minus 2 x whole power 5, and then you expand this and write it out as 1 minus 10 x plus 40 x squared minus 80 x cube plus 5 times 16 is 80 x power 4 minus 32 x power 5, and you are done. Let us try a couple more. How will you do this? X plus 1 by x whole power 6. So, in the first chance you pick x 6 times, you get x power 6, you never pick 1 by x, okay. All right. Then in the next chance you pick x 5 times and 1 by x just once. So, it is x power 5 times 1 by x, which makes it x power 4. And how many different ways can you do this? 6. So, it is 6 x power 4. Then the next time around you pick x 4 times and 1 by x twice. So, x 4 times means x power 4, 1 by x twice means 1 by x squared, x power 4 times 1 by x squared gives you x squared. And how many different ways can you do this? 6 choose 2, 6 C 2. So, that is 6 into 5 by 2. Then the next time around you pick x 3 times 1 by x 3 times, x 3 times 1 by x 3 times makes it 1, right, no exponent at all. So, 1, and how many different ways can you choose 3 x's out of this? 6 C 3, that is 6 into 5 into 4 divided by 3 into 2 into 1. So, that is equal to 20. And then the next time you pick you pick x only twice and 1 by x 4 times, right, and that is again 6 C 2 times. And next you pick x only once and 1 by x 5 times, and that gives you 1 by x power 4. And how many different ways can you do that? You can do that 6 different ways. And lastly you pick only 1 by x, so you are left with 1 by x power 6. Okay. So, what I am trying to do is I am trying to give you some practice so that you do not have to memorize that formula at all, right. This formula is not needed, although it is there in the book. This expression, this complicated thing should be in your mind, you do not have to memorize it, right. You can work it out just from first principles each and every time, and I think in a lot of ways that is easier to do than to remember, because there are already so many things that you have to remember, you do not have to remember this extra information, okay, especially when you can work it out every time, it is fast enough. With a little practice you will see that it just comes naturally. So, let us try one more. So, this is also there in the book, 2 by x minus x by 2 whole power 5. It is somewhat similar, but let us do it. So, first time you pick all 2 by x's. So, you get 2 by x whole power 5. The next time you pick 1 of the minus x by 2's and 4 of the 2 by x's, right. So, you get a minus because you have picked minus x by 2 only once. So, you end up with minus, and x by 2 into 2 by x whole power 4 is nothing but 2 by x whole cube. And how many different ways can you do this? 5. and the next time you pick 2 by x just 3 times and x by 2 minus x by 2 2 times. So, when you are picking minus x by 2 2 times, it becomes a plus, and x by 2 whole squared times 2 by x whole cube leaves you with just 2 by x. And how many different ways can you do it? 5 c 2, which is 10, and then the next time you pick 2 by x twice and x by 2 3 times, minus x by 2 3 times. So, you end up with a minus, and x by 2 goes away with 2 by x, but you have done this 3 times, you have done this 2 times. So, you are left with minus x by 2. And how many ways can you do this? You can do this 5 choose 3, 5 choose 3 is nothing but 10, it is the same as 5 choose 2. And then you pick 2 by x just once, x by 2 4 times. So, that leaves you with minus x by 2, no, you have chosen minus x by 2 4 times. So, it becomes a plus x by 2 whole cube, right. And how many different ways can you do this? 5. And lastly, you do not pick 2 by x at all, you pick only minus x by 2 5 times. So, minus to the power 5 gives you a minus, and then x by 2 whole power 5. So, that is your answer. Okay. So, we are going to wrap up our first lecture on the binomial theorem here, and net what did we figure out? We figured out the most important thing. This is our binomial theorem, but what is more important is the way we arrived at the binomial theorem. The way we arrived at it was by breaking it up into several pieces. A plus b whole power 7 was broken up into 7 pieces, and then you keep picking, right. The first time you pick all a's, you get a power 7. The next time you pick only one b and 6 a's, you get a power 6 times b. And how many different ways can you pick one b? You can pick it from this one, you can pick it from this one, or this or this or this or this or this. So, there are 7 different ways to do that. Then the next time you pick 5 a's and 2 b's, right. So, you get a power 5 times b squared, and how many different ways can you do that? 7 c 2, and then 7 c 3 times a power 4 b cube, 7 c 4 times a cube b power 4, 7 c 5 a squared b power 5, and so on and so forth. So, this is in a nutshell the gist of the entire chapter. All the problems revolve around this expression, the way you made you broke this up and found the result. Okay, thank you for your attention, and hope to see you soon.